Please welcome our second speaker, Julie Cass. Julie is a petrophysicist with over 20 years' experience in the oil and gas industry across Australia and the UK. We're very lucky to have her working in our energy, geoscience and carbon strategy branch.
Thank you. Let me begin today by respectfully acknowledging the traditional peoples of the land on which we are gathered, the Whadjuk people of the Noongar Nation, and pay my respects to their elders, past and present, and emerging leaders. We've all heard about the energy transition and the important part CO2 sequestration needs to play in achieving emission reduction targets. In May 2021, the Ministerial Task Force on Climate Action identified enhancing CO2 sequestration as a key government priority. This task force has provided funding for a refresh of the carbon dioxide geological storage atlas for Western Australia. The refreshed atlas has an increased scope, updated prospectivity, and a strong focus on providing statewide data sets. Much has been published in recent years on how to screen basins for CO2 prospectivity. As you can see from this slide, unlike hydrocarbon exploration, CO2 storage prospectivity is strongly influenced by the location of emission sources, existing infrastructure, and land use, as well as geological information. Our atlas focuses on a subset of geological criteria for basin screening. We are finding and compiling data sets that complement the assessment of critical pressure and temperature, capacity, and containment. Critical pressure and temperature are important as sequestration targets are the formations where CO2 can be stored as a supercritical fluid. Supercritical fluids have properties of liquids and gases. They expand to fill all available space, just like a gas, but they have densities like liquids, which just means they take up a whole lot less room. For this purpose, we're creating a temperature database. The WAPM's archive hosts many different types of temperature data. Our database captures the source of the data and the contextual information required to interpret it. Using these data sets, a subsurface temperature profile has been modelled, as per this example from the northern Perth Basin. The models and temperature database will be published through WAPMs. There are many aspects that need to be considered to define capacity. First, we need to consider gross rock volume. Sequestration targets can be structured or stratigraphic. These targets require reservoir and seal pairs. They include uneconomic discoveries, depleted oil and gas fields, and water-bearing aquifers. Or they can be unstructured, like the Southwest Hub CCS Research Project Area of Interest. This comprised a thick sedimentary sequence with no traditional sealing formations. Here, permanent storage is achieved through residual gas trapping, solubility trapping, and mineral trapping via the long, tortuous flow path of the migrating CO2 plume. Within the gross rock volume, we need to consider the reservoir properties to understand how effective that capacity is going to be. In addition to the reservoir quality properties common in the petroleum industry, such as shale volume, porosity, and permeability, we're also interested in pore and fluid properties to understand poroelastic relationships and chemical interactions with existing pore fluids over time. And lastly, heterogeneity, where the influence of lateral and vertical reservoir continuity and the impact this has on the flow path of injected CO2 is characterised. The Sleipner field in Norway is a beautiful example of this, showing initial lateral plume migration is preferenced over vertical plume migration due to the contrast in vertical and horizontal reservoir properties. The data sets we are leveraging for assessing gross rock volume include well log data, formation tops, seismic surfaces, and well correlations. The data sets we are leveraging for assessing reservoir properties include well log data, routine core analysis, and petrophysics, mostly open hole submissions. Future work is required to compile datasets to complement the assessment of pore and fluid properties and heterogeneity. WAPMs is awesome and an invaluable resource for the state, but if you want to sit down and do some interpretation on a regional basis, it's going to take you a while. My initial dump of log LAS files contained over 8,000 files. If you wanted to manually load this up and create a spliced set of logs with consistent names, units, and accurate header details, you'd be busy for well over 2 years. Hence me, the crazy lady with the frying pan. Instead, I've written a series of Python scripts to automate this process. Running through the scripts takes about a couple of days for this volume of files. Unfortunately, I haven't been able to automate the process of merging across the LAS files. And this is because it's very difficult to automatically detect open hole versus cased hole or acquisition depth versus depth shifted. And you do require a bit of QC of what you've come out with at the end of the Python script. This took about 2 months to complete for the Perth, Canning and Officer basins, so still an incredible improvement on traditional data loading timeframes. Each well in the state now has a consistent LAS file with this suite of log data. Where a log wasn't recorded in a well, there's null values, and this ensures that each well can be loaded with a single template for each basin. I consider the final result about an 80% solution. There are some obvious data gaps, and I've investigated many of these while writing the code. There's a variety of reasons for the gaps, but most of them require some sort of manual intervention to fix, purely because of the varying quality of what's been submitted in the first place. There's no plan to resolve these gaps in this piece of work, but hopefully we'll be able to do that sometime in the future. The other data set that's included in the well files is the deviation data. This is also provided as a separate file. If there was no deviation data for a well, it's presumed that it was vertical, and if there's an inclination only, the azimuth has been assumed to be 0. This map shows the final distribution of wells with log data, also highlighting wells that have temperature data, and the location of the state's major CO2 emission sources. We are refining the formation tops for each of the basins, using biostratigraphy to unify the peaks across all the decades of different data acquisition and all the different operators. This type of regional review has not been attempted in the state waters of the Northern Carnarvon Basin for more than 20 years. Depth maps like these from the Officer Basin are being collated from various sources of open file seismic mapping combined with new seismic interpretation. And this ensures we actually tie all of the well data and available stratigraphic data. And to support and sometimes supplement the seismic interpretation, well correlations across each basin are being produced. These allow us to visualise trends in gross rock volume and reservoir quality. Containment, or seal quality, is another important aspect that must be studied and understood in a CO2 storage project. For structured reservoirs, the seals need to be studied. Their thickness, facies distributions, and rock properties within each facies need to be characterised along with rock strength. And in unstructured reservoirs, the reservoir thickness required to achieve permanent storage through residual gas trapping, solubility trapping, and mineral trapping also needs to be assessed. Many of these data sets being compiled in this piece of work complement seal property analysis. Regional data sets quantifying seal strength are currently very limited across the state, and compiling these data sets has been left as future work scope. So I encourage you to get online and start downloading some of these new data sets. All the data for all the temperature data for all the basins is available now, and well data and deviation data for Perth, Canning and Officer Basin are available, with the other basins soon to follow. Thank you.